Okay, let's take a look at the basic structure of the atom. The nucleus is found at the center of the atom. This is where most of the mass of the atom is concentrated. Within the nucleus, we find protons. Protons have a positive charge. Neutrons are also found in the nucleus and have no overall charge. Electrons are tiny particles that are found moving around the nucleus. Electrons carry a negative charge. The path the electron takes around the nucleus is called an orbital. The orbital makes up most of the volume of the atom. This means that most of the atom is actually empty space. Because the masses of the proton, neutron, and electron are so small, we describe their sizes relative to each other. The proton and neutron are both the same size, so we say they both have a relative mass of 1. The electron is tiny. It has a relative mass of just 0.0005. The mass of the electron is negligible compared to the proton or neutron, so in describing the mass of an atom, we only consider the mass of the neutron and proton and ignore that of the electron. So now let's summarize the properties of the neutron, proton, and electron. The proton has a relative mass of 1 and a relative charge of +1. The neutron has a relative mass of 1 and has no overall charge. The electron has a relative mass of 0.0005 and a relative charge of -1. Each element has its own chemical symbol. The number at the top of the symbol is called the mass number. This tells you the number of protons and neutrons in the nucleus of that element. The number at the bottom is called the atomic number. This number tells you the number of protons in the nucleus of the element. It is the number of protons in an atom that determines which element it is. For example, hydrogen has 1 proton, lithium has 3. In a neutral atom, the number of protons and electrons is the same, so the atomic number also tells us the number of electrons present. Okay, let's look at some examples. Fluorine has a mass number of 19 and an atomic number of 9. If the atomic number is 9, then the atom must have 9 protons, and as a neutral atom must also have 9 electrons. In order to calculate the number of neutrons in fluorine, we simply subtract the atomic number from the mass number, which gives us 10. Magnesium has a mass number of 24 and an atomic number of 12. If the atomic number is 12, then this atom must have 12 protons, and as a neutral atom must also have 12 electrons. In order to calculate the number of neutrons in magnesium, we simply subtract atomic number from mass number, which gives us 12. Now let's take a look at ions. Ions are atoms that have a charge. We will take hydrogen as an example. Hydrogen has 1 negative electron and 1 positive proton. These charges cancel out, leaving it with no overall charge. If hydrogen loses its electron, it will be left with its single positive proton and therefore have an overall charge of +1. We call positive ions cations. If hydrogen gains an extra electron, it will now have 2 negative charges and 1 positive charge from the proton. It will therefore gain an overall charge of -1. A negatively charged ion is called an anion. We can represent ions by placing the chemical symbol of the element in square brackets and placing the ion's charge in the corner. Potassium has lost 1 electron, so has a 1+ charge. Calcium has lost 2 electrons, so has a 2+ charge. And oxygen has gained 2 negative electrons, so has a charge of 2-. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. For example, hydrogen can exist with 1 proton and no neutron and therefore have a mass number of 1. Or it can exist with 1 proton and 1 neutron and therefore have a mass number of 2. It can also exist with 1 proton and 2 neutrons and therefore have a mass number of 3. The chemical properties of these isotopes will be the same, as chemical properties of an element are dictated by electrons, not the mass of the atom. However, different isotopes can have slightly different physical properties, for example, different densities and rates of diffusion. Okay, thanks for watching and don't forget to visit mrdoran.co.uk.